Hey everybody! In this video, we are going to talk about programming. Definitely, we will going to learn about this. Okay, because somewhere it's important, and somewhere we don't have. We just forget the basics. So we're going to focus on what is programming. Okay, so actually, what is the purpose of this video is actually turning ideas into reality, one line of code at a time. Okay, so let's suppose this is a binary code, as you know, like think, code, and create. This is the philosophy of this lecture. So first of all, the in a nutshell summary. Okay, what is actually programming? So programming is essentially writing. Okay, it's just a writing a highly detailed. So it is a completely highly detailed step by step recipe. It's a kind of a recipe that tells computer exactly how to perform a specific task. Let's suppose you're ordering someone, like you are ordering someone, but at that time you have to define, okay, what he needs to do. Specifically, you need to define, okay, what you need to do and how you're going to do that. So simply, when you're going to when you want to perform a task by a computer, okay, so at that time you had to define a specific task to that computer, and for that you have to write something, like you have to write some inputs, you have to give some inputs, and you give those inputs in the form of writing. Okay, like you are using keyboard and writing some kind of prompts. So programming is essentially writing a highly detailed step-by-step recipe is a kind of program that tells a computer exactly how to perform a specific task, because computers are incredibly fast but completely lack common sense. So computers बहुत fast होते हैं but they don't have common sense, they lack it. Okay, so programmers use a specialized language. So programmers use a specialized language to translate human ideas. Let's suppose a person is really intelligent but he is not able to understand our language, so it's just dumb for us. Yeah, but in that situation, if it's a PC, we'll have some ways to communicate with those machines. Got it? And that languages are called programming languages. but before that but before that, there are some specialized languages which has to translate human ideas into logical, flawless. It's flawless. Okay, it's flawless. Okay, logical and flawless instruction. Just wait a minute. It's flawless instruction the machine can execute, and when machine understand your language, when machine understand what you need to do, then machine execute that core idea. What you need to do, you just need to think. You have to think, okay, what you're going to write, and then you have to write, okay, what once you think, and then you have to write you write. Computer does exactly that, and what you write, computer does that. What you think is not important. What you think and then what you write, then computer perform the basic perform acts perform, then computer performs some of action on the basis of what you have provided or what you have given that machine. Yeah, so I hope you understand what is programming actually. Next, we have key concepts and vocabulary. First thing, code. That's called a programming language. Now, what is the written vocabulary and grammar used to communicate with the computer? So actually, what is code or programming language? It is just a vocabulary and grammar which is used to communicate with the computers. When we have to talk with a person. So at that time, we need some grammar and we need some vocabulary. Like right now, I'm speaking to you in English. So it's a language. Okay, and in that language we have two things. One is vocabulary and the other is grammar. Okay, grammar makes arrangement or sentence structure, and vocabulary is the word which is important to communicate. Okay, so analogy, just like a Spanish, I already told you the analogy, or Mandarin allow you to talk to the other people language. Like apart from that, like, okay, similar like languages like a Python, JavaScript, or C++ allow you to speak to microchips. So these are the microchips, and these are the microchips, and you're going to talk with them in Python, JavaScript, or C++. These are the languages which helps you to talk with this machine, this tiny machine. You understand? I hope you understand. Okay, now next is algorithm. You understand, okay, what's called. Now next is algorithm. What is actually algorithm? Algorithm is a set of precise step-by-step instructions or instructions designed to solve a problem or complete a task. Okay, so algorithm just like a formula. It's just a formula, like you are using formulas. Like think analogy. Think of it as a recipe. That's like a recipe of baking cake, and means formula. If you skip a step or mix the ingredients out of order, the final product is ruined. Okay, simply, if you just miss the formula, like let's suppose you are using somewhere a plus b the whole square. Okay, and at that place I mean, in the place of plus, you use just negative sign. Okay, what would be happen? The result is going to completely ruin or completely change. That is the algorithm. Algorithm just like formula or step-by-step instructions, which is has to design solve a problem or complete a task. With the help of, we can solve a problem, or either we can solve a problem or we can complete a task. That is algorithm. Algorithm just like formulas, okay, and coding or programming language, just a language. That's it. Next is syntax. Syntax, the strict grammatical rules of a programming language. When we have to understand grammar, okay, so actual syntax is the grammar, okay, syntax is the actual grammar, how we have to, okay, let's suppose we know, okay, what print does, what a function does, okay, but we don't know how to write those functions. So let's suppose we know vocabulary, but we don't know how to structure those vocabulary in a sentence. So we are not able to perform a certain task, we are not able to perform certain tasks. So what we should do, we should at the time we should focus on grammar, okay. So that's where syntax, that's where in programming language syntax comes, okay. So in that situation we had to use grammatical rules for like syntax is a grammatical rules for programming language. That's it. Analogy, if you write the cat, okay, set on the mat, this is a sentence structure without a period. Let's suppose here is no period, so humans still understand you, okay. In a programming language, leaving out a single semicolon or bracket can cause the entire system to crash. अगर हम किसी like in a programming language, if we just leave, like if we are not going to use a period, if you're not going to use full stop, like when we think that we use in English, in similar way, if you are not going to use semicolon or bracket, okay, semicolon or bracket in a programming language, then entire system is going to crash, like entire result is going to crash. That's 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 what syntax is. So that's why syntax is really important. Now understand code, that's programming language, algorithm and syntax. You understand three things. Next one is compiler or interpreter, okay. Compiler, that is a digital translator, so it's just like a translator, okay. Let's suppose you know English, someone knows Chinese, but there's a one person who understands English and Chinese, both of these languages. So that person work as a translator. Let's suppose you have to deal with the Chinese one, so you're going to say something, and the person who acts as a translator, he will translate your sentences for him, okay, like for the Chinese person. So in similar way, compiler or interpreter, he interprets the thing. Though compiler interpreter is the digital translator that converts the human readable code, so the codes that human can read, you write, actually we write that code into binary code, that is ones and zeros, okay. So actually what computers understand, ones and zeros, that's it. Like computers understand only ones and zeros, that's called machine language, okay. That's called machine code, ones and zeros, okay. Like this is 10 10 10 blah 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 blah, jo bhi hai, okay. So here code, we write some code in our language, like that's human can understand, okay. And there's compiler in between human language and machine code that compiles, so that interprets to the machine. So I hope you understand what is actually compiler or interpreter. Now you understand. Now we have to understand how it works. Actually, what is the process? What is the step by step? First thing, identify the problem. So first we have to define exactly what we want. Okay, what do we want? Okay, what should computer to do? Okay, like what you want the computer to do. So that is the first thing. You have to identify the problem, or you have to identify the, okay, for which problem you need a solution. So you are going to you're going to give a prompt to the computer, or you're going to give some instruction to the computer, okay. Like let's suppose calculate the fastest route home, okay. Let's suppose you have to go to your home, you want to go your home, and you at the station, like railway station, police, or whatever kind of station it is, and you don't know what is the smallest way, what is the fastest way to reach there. So that would be the problem, and you're going to give that problem to the computer. What happens after? Design by logic, that's called algorithm. So here are some logics. You map out the step-by-step logic of the solution before writing any code. You map out the step-by-step logic of the solution. So you just mention the whole step-by-step logic for the solution, okay, how the computer can get the solution. Next one, we have to write the code. So you translate your logic. So we translate a logic into a programming language inside the text editor. So in that situation, we have to we have to translate. 1 minute. When we write the code, you translate your logic into programming language, okay. Let's suppose whatever logic we have, firstly we just found the problem, then we just map out the what would be the problem, like in step by step, and then we just translate that idea into programming language inside the text editor, okay. And then we just write that in the text editor. What happens after, like, compiler translator that translates or interpreted, like that, it's a software tool which translates our written code into raw binary instruction. And then what happens when we click on the run and debug, so it runs the program. You run the program and hunt down any errors. So when we run the program, we find some errors if there is, otherwise it works flawlessly. Okay, that's it. Why it matters, why programming is important nowadays. No, next, why it matters. Okay, so programming is the invisible engine powering our modern world. So in our modern world, it is an invisible engine. So this is the engine we can see, but it is powering the modern world. From the microprocessors, like processors, okay, it's a somewhere it is AI edit node, so somewhere it makes some errors, definitely. Okay, so from the microscopic microprocessors in our washing machines, so in our washing machine we have some microprocessors, to the complex algorithms driving global financial markets, medical devices, and space exploration. Code which is useful, that code transforms abstract ideas into functional automation. Let's suppose abstract ideas which we just think in our minds, or think in our brain, that kind of ideas are just abstract ideas. But when we have to perform those ideas in functional automation, at that time we use code. So learning to program shifts you from a passive consumer of technology to an active creator. So once you learn the programming language, you are no more a passive consumer. Now you are an active creator, though. You can create something you want. I mean, if you have some problem, you can solve it, giving you the power to build tools that can instantly reach billions of people. So with the help of this, you can reach billions of people. You can connect with the billions of people at a single time. That's it. That's why it's important. Next one is common pitfall or misconception. What is some misconception? What are some common pitfalls? Misconception is that you need to be a math genius to learn how to code. That is just a misconception. That's not completely, and that's just irrelevant. What is actually reality? Programming is far more about logic. Programming is just about logic. You don't have to be a mathematician. You just don't need to be a mathematician. So it's just like reality. The programming is far more about logic, organization, and creative problem solving than advanced calculus. You don't have to think about calculus and all like that. Okay, you just have to think about logic, how to organize something, and how to be creative in problem solving skills. If you can write a clear set of direction, like if you are able to write clear set of directions, you have the foundational thinking required to program. Next misconception: computers are highly intelligent. This is they are just dumb. The reality, computers are actually extremely obedient but incredibly simple minded. Okay, you can understand them easily. They are extremely obedient. They obedient you. Okay, they will do exactly what you tell them to do. Okay, even if your instructions accidentally tell them to crash themselves. That's it. Quick revision is that programming is just writing step-by-step instructions for a computer. Key terms: code, that's called key terms like code language, algorithm steps, syntax rules, and compiler, interpreter, translator. Process like, first you need to find problem, then you have to find the logic, then you have to write the code for that, then translate it. You have to compile it, and then you have to run on debug. What it matters? It matters because it powers the world and turns. Wait a second. Okay, why it matters? It matters because it powers in the world and turns ideas into impact. Okay, it focus on what? Wait a second. Focus on logic, clarity, and practice, not just math. That's it.